Okay, question 9. We've got an arithmetic sequence. These are our terms, and we've got to show that 4x squared minus 3 is not in the sequence. We've got to find x first, I would suggest. So the thing about an arithmetic sequence is between term 1 and term 2, there will be a difference, and that same difference will exist between term 2 and term 3. So we can set up a simultaneous equation and find out what that difference is, and then hopefully the value of x will pop out. So there is the sequence again, and I've numbered the terms. Let's work on these differences. So I can say that 2 minus 1 is equal to 2x minus x minus 1. This just becomes x minus 1. And so now let's work out the difference between term 3 and term 2. Term 3, multiplying the top line out, is 4x plus 6 divided by 6 minus x. And we take away the previous term, which is 2x. So let's put it on a common denominator of 6 minus x. This is 4x plus 6. And then we take away 2x and multiply that by 6 minus x. A quadratic is arriving. Okay, that is equal to 4x plus 6 minus 12x plus 2x squared. And that is over 6 minus x. So simplifying that, just putting the x's together and reordering it, I get 2x squared. Negative 12x, positive 4x is negative 8x. And we get plus 6. And that's divided by 6 minus x. And because the question says this is an arithmetic sequence, these two results are equal. So coming over here I get, and cross-multiplying, I get that 2x squared minus 8x plus 6 is equal to these two guys multiplied together. X minus 1, 6 minus x. So multiplying the right-hand side out, I get usual routine. We get 6x. Negative times negative is positive, so this is positive x, negative 6, and negative x squared. I'm going to put everything on the left-hand side and equal 0. Doing the x squareds first. Negative x squared comes and joins the 2x squared and makes 3x squared. The x's now, I've got negative 8 on this side, and that's joined by a negative 7x, which makes negative 15x. And I've got a positive 6 to be joined by another 6 from here, which will be positive as well. So this is positive 12. Straight away, there's a factor of 3 to come out of this. So I get, that's a slightly easier factorization. 4 is going to be 4 and 1. They're both going to have to be negative, and this is x here. So therefore, x is equal to 4, or x is equal to 1. We need to check these results, certainly for the first 3 terms, and see whether we do get an arithmetic sequence as promised. Let's try x is equal to 1 for the first 3 terms. If x is equal to 1, I get 2, and 2, 2. Which is not an arithmetic sequence, and I can reject x equals 1 as an answer. So now let's try x is equal to 4. I get 5. I get 8, so I'm hoping this is going to be 11. 2 times 4 is 8 plus 3, so that's 22. I'm just going to write it here, divided by 2, which is indeed 11. So x is 4 is correct. So all we've now got to do is check 4x squared minus 3. So the sequence must be equal to, it's based on 3n, and the first term gives us 5, so this is 3n plus 2. So now we've got to sub x is equal to 4 into the term that they've given us, which is 4x squared minus 3, and we get x squared is 16, 16 times another 4 is 64, minus 3 is 61. So there should be a value of n that satisfies this, and the answer will be an integer. Moving that 2 across, I get 3n is equal to 59. And I think you can see that n is equal to 59 over 3, which doesn't equal an integer. So therefore I can say that 4x squared minus 3 is not in the sequence. And there's the proof.